Welcome to the Explainer. Today we're going to talk about something every single person who writes code runs into, especially when they're just starting out: Python error messages. We're going to take them from being this source of panic and turn them into your most helpful friend.
So if you're new to coding, this probably looks pretty familiar. You write some code, you're all excited to see what it does, and then bam, you get hit with this wall of red text. It's so easy to feel like you messed up, but I promise you, that is not what's happening here.
I know it looks super complex, maybe even a little intimidating. But what if I told you this isn't a sign you failed? It's just your computer trying to have a very, very literal conversation with you. You know, learning to code is like learning any new language. And this is just how the computer tells you it doesn't quite understand what you just said.
Now, to understand this language, it really helps to know that Python's error messages basically fall into two main categories. And once you can tell the difference between them, that scary wall of text starts to look a whole lot less like a problem and more like a roadmap.
Okay, let's dive right in, starting with syntax errors. Honestly, these are by far the most common type of error you're going to see when you're first finding your way around Python.
Think of a syntax error like a simple typo or maybe a punctuation mistake in a sentence. You know that classic example, let's eat grandma versus let's eat grandma? That one little comma changes everything. Well, in Python, a syntax error means the structure is so off the computer can't even begin to figure out what you meant.
Take a look at this super simple line of code. To you and me, it seems pretty obvious what we're trying to do here. But to Python's very strict grammar checker, something's definitely missing. So let's see what Python has to say about it.
And this is Python actually trying to be helpful. It shows you the exact line, and it uses that little caret, that little arrow, to point to the very first place it got confused. The message syntax error, invalid syntax, is just Python's way of saying, I got to this point right here, right before the word print, and the grammar just didn't make sense to me.
So that little arrow is your big clue. Python is pointing at print because it was expecting something else entirely. After while true, Python's grammar rules say there has to be a colon, the two dots. That missing colon is the mistake, and the arrow points to what comes right after the mistake.
Okay, let's move on to the second type of message. These are called exceptions, and they're a little bit different. They build on what we just learned.
An exception is what happens when your sentence is grammatically perfect, but what you're asking is just logically impossible. It's kind of like telling someone to go drink the sky. I mean, the grammar is fine, but the instruction itself just doesn't make any sense in the real world. Python understands the words you wrote, but it just can't perform the action.
And here's the key difference, all in one spot. Syntax errors are all about the form of your code, the grammar. Python spots those before it even tries to run anything. But exceptions are about the meaning. They only pop up when Python is actually running your instructions and hits a logical wall.
This is a classic example of an exception. The code 10 times 1 over 0 is written perfectly, syntactically speaking. But when Python actually tries to run it, it gets to the 1 over 0 part. And since dividing anything by 0 is a mathematical impossibility, Python just has to stop and raise a zero division error.
Oh, here's another one you will see all the time. Again, the grammar is totally fine. But Python gets to the word spam and has no idea what it is. We never created a variable called spam. We never told Python what it was supposed to be. So it raises a name error, which is basically its way of saying, hey, what's spam? You never told me.
And this one is a type error. We're trying to add a string, that's the character 2 in quotes, to an integer, the number 2. To Python, this is like trying to add a word to a number. It just doesn't make sense. So it tells you exactly what the problem is. You can only add a string to another string, not to a number. They're different types.
Okay, so when you see one of these longer messages, here is the absolute best trick. Read it from the bottom up. I'm serious. The very last line will always give you the most important info, the specific error type, and a short message about what went wrong. The lines above it, that's the traceback, and it's just a map showing the exact path your code took to get to the problem. So now that we can actually read these messages, let's talk about how to manage them. You don't have to just let your program crash. You can actually anticipate these errors and tell Python what to do when they happen.
We can do this with something called a try-except block. And it's a super powerful tool that works exactly like it sounds. You basically tell Python, hey, try to run this piece of code for me. If it works, awesome. But except, if a specific error happens, don't crash. Just jump over here and run this other piece of code instead. It's like having a plan B.
This is a fantastic real-world example. This code asks a user for a number. It tries to turn their input into an integer. Now, if the user types 10, the code works fine and the loop stops. But what if the user types the word 10? Normally, that would crash with a value error, but because we wrapped it in a try-except block, it catches that specific error, prints our friendly message, and the loop just continues, asking them again, no crash.
And really, this is the whole point. You can build much stronger, more professional, and way more user-friendly programs just by planning for things to go wrong. Instead of letting errors stop your program dead in its tracks, you can handle them gracefully.
All right, so let's recap the key ideas that are going to make up your new programming superpower.
So remember these things. First, errors are messages, not failures. They're trying to help you. Second, syntax errors are grammar mistakes, while exceptions are logic mistakes that happen when the code is running. Third, and this is the big one, always read the last line of an error message first. It has the answer. And finally, you have the power to control errors with try and except. Getting these ideas down will completely change how you code.
Look, every single programmer, from the absolute beginner to the most seasoned expert, writes code that has errors. It is just part of the process. The only difference is that an experienced programmer doesn't see an error as a wall. They see it as a conversation. So the next time you see that wall of red text, don't panic. Just take a breath, scroll to the bottom, and listen to what your code is trying to tell you.